Welcome to The Explainer. Today, we're going on a little cosmic detective journey to uncover the secrets of some of the most important machines you've probably never seen. So let's start with a mystery. Picture this. You're outside at night, looking up at the stars, and you spot this tiny point of light. It's moving in a perfectly straight line. It's not blinking like an airplane, and it's not a quick flash like a meteor. So what is that thing? Well, that moving light is a satellite. But what are these things really? And what do they do for us? All right, let's dive in. First things first, we need to answer the most basic question. What exactly is a satellite? You might be surprised to find out the answer is actually bigger than you think. A satellite is, simply put, anything that orbits another bigger thing. And what's interesting here is that this definition includes way more than just the machines we build and send up there. See, there are two main types. First, you have your natural satellites, like our moon orbiting the Earth. Heck, by this definition, the Earth itself is a natural satellite of the sun. Then you have the man-made or artificial satellites that we launch into space on top of rockets. And that special curved path that they all follow, that's called an orbit. You can think of it as a giant, invisible racetrack in the sky, and the one force that keeps everything on that track is gravity. It's kind of amazing to think that we only started sending these things into space a relatively short time ago. The whole thing really kicked off in 1957, when the Soviet Union launched Sputnik 1. It was this little sphere about the size of a beach ball, and it officially started the space race. The US quickly followed with Explorer 1, and then, just 2 years later, we got our first ever photo of our own planet taken from space. Can you imagine seeing that for the first time? Okay, so that brings us to our next big question. How do all these thousands of satellites actually stay up there without just falling out of the sky? And it's a great question, right? Earth's gravity is incredibly strong, so there has to be something else going on. And there is. It all comes down to a brilliant, high-speed balancing act. This idea actually goes all the way back to Isaac Newton. He imagined firing a cannonball from a very tall mountain. If you fire it kind of slowly, it just lands nearby. Fire it faster, and it lands farther away. But, and here's the genius part, if you could fire it fast enough, it would fall all the way around the world. It would be in orbit. And that thought experiment perfectly illustrates the solution. It's this cosmic tug of war. A satellite is moving sideways at about 17,000 miles per hour. That incredible speed wants to fling it straight out into space. But at the same time, Earth's gravity is constantly pulling it back down. When those two forces are perfectly balanced, the satellite is always falling, but it's moving sideways so fast that it just keeps missing the ground. So now that we know what they are and how they stay up there, let's get to the really cool part, all the incredible jobs they do for us, right here on Earth. Right now, there are more than 8,000 active satellites orbiting our planet, and every single one has a special job. They are truly the unsung heroes of our modern world. So, if you've ever used a map on your phone, you've used satellites. You're tapping into the Global Positioning System, or GPS. And it's not just one satellite, it's a whole team, a constellation of about 30 of them, working together, all from 12,000 miles up, to tell your phone exactly where you are. Weather satellites are basically our eyes on the atmosphere. From their amazing vantage point in space, they're constantly taking pictures of cloud patterns and tracking huge storms like hurricanes. This gives meteorologists the vital data they need to make accurate forecasts and help keep all of us safe. Communication satellites work like giant mirrors in the sky. TV signals, phone calls, internet data, it all gets beamed up to them, and they amplify and bounce those signals right back down to a different part of the world in just a fraction of a second. They connect us all instantly. And then you've got the Earth observation satellites. These are the scientific detectives. They monitor everything from the smoke of distant forest fires to the shrinking of polar ice caps. They help us track illegal fishing and even measure the health of farm crops. They're basically giving our planet a constant checkup. And of course, the biggest, most incredible satellite of all is the International Space Station. This thing is a massive science lab and a home for astronauts that's as big as a football field, orbiting Earth and doing experiments that you just can't do with gravity getting in the way. So, we have solved the mystery of that moving light in the sky. Let's wrap up our investigation with the 5 most important things to remember from all this. Okay, let's recap. First, a satellite is anything that orbits a larger object. Easy enough. Second, the moon is a natural one and Sputnik 1 was the first man-made one. Third, they stay in orbit by perfectly balancing their incredible speed with Earth's gravity. Fourth, their jobs are vital, powering our GPS, weather forecasts, and communications. And finally, the biggest of them all, the ISS is an actual home for astronauts in space. This technology is always growing, with new constellations of satellites launching all the time, which leaves us with one final, very exciting question. What new challenges will we solve with our helpers in the sky? The possibilities are as vast as space itself. Keep looking up.